Hello everybody, welcome to exact classes. This is my first lecture over the YouTube, so please apologize me if I'll commit any mistake. We'll study today the vectors. We'll go through the definition of vector first of all. Vectors are the physical quantities which have magnitude as well as directions. Vectors also obeys the law of vector addition, that is also known as the triangle's law. Examples of vector are as follow: velocity, displacement, etc., etc. There are a lot more examples. We will be aware about them as we'll study further. Representation of vector. After the definition, we'll deal with the representation of vector. How we can represent any vector. And vector can be represented by an arrow having a tail and a head. Vector's direction is from tail to head. Here I have marked a arrow, and here via one arrow I have marked tail, and via another I have marked the head. For example, displacement vector can be represented as S vector, and so on. A lot more vector can be represented by some symbols having an arrow above them. Sign of a vector is because of its direction. Here it is very important line. Sign of a vector is because of its direction. That is because of its vectorial nature, not because of its magnitude. Because magnitude of every vector always remains positive, always remains the positive. It is the direction, or it is because of the vector that any vector bears a negative positive sign. For example, here I have mentioned AB equals to negative of 4 I cap. Here clearly magnitude of this vector is 4 and its direction is towards west in Cartesian representation, or this can be also written as negative of I cap. Now we'll deal with the angle between the vectors. Angle between the vectors. When two vectors are joined tail to tail or head to head, then the smaller angle between them is the angle between the vector. Here the most important thing is the smaller angle, or tail over tail or head to head. Means while looking for angle, we must look that whether the tail is over tail or head is over head, or if head is overhead or tail is overhead, then we will look at the smaller angle, and that smaller angle will range from 0 degree to 180 degree. By example it will become more clear. Here a vector and two vectors are marked, and angle between them is 45 degree. Clearly we can see that the tail of b vector coincided with the tail of a vector, and hence the smaller angle between them is 45 degree, and this angle will be the angle between a vector and b vector. In a similar way, in another example b, example number b, we can see that there are two vectors, and the head of one of the vector a is combined with the tail of the other vector b. Hence it is not fulfilling the criteria of angle between the vector. For then clearly 60 degrees is not the angle between a and b vector, because the head is not over head, or tail is not over head, not over tail. Hence to make the criteria of angle between the vector, we will produce a vector, and we will produce a vector further, and we'll make orientation like a vector and b vector will be oriented like this, and like this, in such a way that the tail of a vector again combine with the tail of b vector, and in this case the angle is 180 degree minus 60, hence 120 degree. So gentlemen, it's very important to look for the condition, look for tail over tail or head over head while writing the vector. While writing the vector, it is very important to look that whether the tail is over tail or head is over head. If it is not so, then try to make it like that. Then only you can be able to give the angle between the vector by just giving the smaller angle, and so on. Here are the two examples also. In both the two example, I have do the same what I have stated above. Now I am proceeding further. Here I have mentioned some point, and these are very important point. One of the point is a vector does not change if it is shifted parallel to itself. Means if we can shift a means we can shift any vector parallel to itself either downward, upward, or anywhere, but it should be the parallel to its original orientation. Means if a is here, a vector is oriented here, I can simply shift it toward above or toward downward also, and I have shifted it for the sake of convenience, for the sake of understanding also. Here I have shifted a vector upward and v vector towards rightward. Now the other very important point is that two vectors are said to be equal only if their magnitude and direction are same. The condition is that magnitude as well as its direction must be the same, and both the vector must represent the same physical quantity also. Addition and subtraction of vector. Two vectors when joined tail to head, then their resultant, their summation, is given by third side of a triangle form with tail over tail and head over head. This line is again very important. Tail over tail and head over head. This is written for the resultant one. Means resultant vector is a vector whose tail coincided with the tail of the one of the constituent vector, and head coincided with head combined with one of the head of the one of the constituent vector. Let's say there are two vector oriented in the following way: a vector and b vector joined by tail to head. Hence tail to head, hence the a and b vector are going to be summed up. They are going to be summing up, and by summing them we will give the resultant vector r, that is the resultant of both these. And hence simply we can see that the tail of resultant vector coincided with the tail of the one of the constituent vector, and head of the resultant vector coincided with the head of the one of the constituent vector. Hence simply we can say that r vector is equals to a vector plus b vector. Example can be given in the similar way as I have stated above: a vector, b vector, and c vector. Simply by seeing it, we can simply say that head of the a vector joined with the tail of c vector, hence these both are going to be summed up, and b vector will be equals to a vector plus c vector. In a similar way, after putting some numerical value also, we can find the resultant of vector. Clearly c is the resultant here, as its head coincided with the head of one of the vector and tail coincided with the tail of one of the vector, a being the 4 I cap plus 5 j cap and b being the 6 I cap plus 5 k cap. By summing a and b as its tail and head are joined, we will get the resultant vector c equals to 10 I cap plus 5 j cap plus 5 k cap. Now the last topic of today is the subtraction of vector. Subtraction of vector is nothing but the addition of opposite of vectors. But addition of opposite of vectors. We all are aware about the addition. I have stated above. I will stated above what is the addition. Now we'll have to deal with the subtraction. And I am saying subtraction is nothing but the reverse of vector addition. Vector addition का उल्टा है, ठीक है? I have I have marked a vector, b vector, and their summation via addition of vector will give r vector equals to a vector plus b vector. But we have to find we have to find the subtraction or the uh, subtraction or the resultant of the vector with the opposite of one of the vector. Hence we'll just reverse b vector downward, we'll make it minus b, and now we'll sum it up with the a vector and we'll get r vector equals to a vector plus negative of b vector, hence a vector, and hence r vector will be equals to a vector minus b vector. Here I have illustrated that the resultant lies in between the two vectors, and previously and in above illustrations I haven't mentioned this type of information, so I am just wearing all that this is correct, that the resultant of any vector lies in between the vector, and this we will study in the parallelogram law of vector addition, and this, also parallelogram law of vector addition will be our next topic. So guys, good to good to with you all. Thank you. Please subscribe and like my channel. Thank you very much.